All right, y'all. So this 9.7 deals with application models for growth and decay. Alrighty, so we're going to look at a formula first. So it's similar to the formula we did the other day with the investments, but we use this formula when we got continuous compounding or continuous growth or continuous decay. So our formula we're going to use is P of T equals P subscript O times E to the K times T. So this formula is used a lot on population. So that's where they're getting the P's from. So P of O here, the P of O is your initial population or amount. E, well, that's Euler's number. We know that already. K is the growth or decay rate. So if it's growth, that'll be positive. If it's decay, it'll be negative. And then T, once again, is time in years. And then our P of T would be the population at any time T. Okay, so they'll give us some problems, and these will say what the initial populations are, the growth rates, and all that fun stuff. So what we're going to do is similar to the investments we did the other day. On number one, they'll have us come up with the function. Then they'll ask us different questions on that, okay? So now the thing about this on the K is just like the interest rate, K has to be in decimal form and not percent, okay? All right, y'all, I'm trying to catch everybody up real quick. All righty. All right, so this example says in 2012, the population of a city was 5.86 million. Then they tell me the exponential growth rate was 2.12% per year. So for part A, they want me to find the exponential growth function. Okay, so this is where we'll come up with the actual formula that we're going to use. So we got the formula up here. So our exponential growth function will be P of T equals, all right, so P of O is my initial population. They gave me, that was 5.86 million. So I'm just going to bring down my 5.86. Now we don't have to put the million because it's understood that this is in millions, okay? All right, next we got Euler's number E, so we bring that in. K, K was 2.12%, but we got to turn that into a decimal by moving the decimal left 2 units and getting rid of the percent. So for this one, looks like I would have to add me a 0 in there so that I get a 0.0212. So that would be our K, 0.0212 times T. So this is the formula they want in Math Lab on part 1, okay? Now, if I know how many years have passed, I can estimate that population. So let's see what part B they want. So this one they say the population of the city in 2018 is what? So they sort of want me to estimate the population of the city in 2018. So looks what we got to figure out is what is our T going to equal? So to find T, we take the year we're looking at, which is 2018. We subtract the 2012, which was the population of the city. So 2012 was when it's based off of. So 2018 minus 2012 gives me a total of 6 years. Now this one, they want me to round 1 decimal place. So what we're finding now is P is 6. Because remember, that'd be after the 6 years, okay? So we got our 5.86 E to the 0.0212 times T, which was 6. So we estimate the population at 6 years, okay? So y'all, I just go to my calculator and punch that in. So I'm going to share that screen with the calculator. So we got 5.86. Now I'm going to use the second ln to get the E with the exponent. And then I'll put in my 0.0212 times 6 years. All right, so remember, we're wanting to estimate this 1 decimal place. So let me hit enter and see what we get. So y'all, 1 decimal place would be like 6.6, but since it's got a 5 after it, I'm going to round that to a 6.7. Now remember, 6.7 million. Now you don't have to write the million, they'll have that million there. But remember, everything we find off of this is going to be off millions, since my initial population was 5.86 million. So now here's a little trickier part of this question. They say the population of the city will be 8 million in about blank years after 2012. So what we're finding on this one is the time. Okay, we're finding the t on this one. So the 8 million, that's going to be our final population that we're looking for. So that'll go in where the P of t is. So our P of t will be the 8 million. That's going to equal 5.86 e to the 0.0212 times t. So up here, we found the final population after so many years. Now we want to look at how many years passed to get to that 8 million, okay? Now we know it's going to be more than 6.7 because after 6.7, after 6 years, it was only at 6.7 million. So it's got to be more than 6 years on this, okay? Now, this one's a little trickier. I got to do a little bit of work before I can solve that for the t. So the first thing I'm going to do on this is divide both sides by 5.86. Because doing that, that's going to get the e by itself over there with the exponent, okay? So y'all, let me pop out my calculator. So we got 8 divided by 5.86. That's going to give me 1.365. Woo, 7713. So I'm just keeping all my digits at the moment. So if that cancels on the right side, I'm left with my e to the 0.0212 t. Alrighty, so nothing else I can do until I bring this down. So to bring all this down, I'm going to take an ln of both sides. And y'all let me do one thing. Instead of actually dividing that out, I forgot about this, but we want to maintain our accuracy. So I'm just going to keep that 8 over 5.86 equal to my e to the 0.0212 t. So I'm not going to divide this until my last step. Because this one, they want me to round 1 decimal place. So to maintain our accuracy, that'll be our last step, okay? All right, to bring the exponent down, we need to do the ln like I said. So we'll have the ln of 8 divided by 5.86 will equal to ln of e to the 0.0212 t. Now, can't do nothing on the left side at the moment, so I'm bringing that down. But y'all remember, ln of e to an exponent equals the exponent. So the ln of e sort of basically cancels itself out, making it a 1. So the right side is just going to be the exponent. The 0.0212 times t. All right, so I got one more step to get t over there by itself, and that's to divide both sides. So I'm going to bring this up. Take the ln, 8 divided by 5.86, and we're going to divide by 0.0212. So those cancel on the right side, and we're left with t. Now, we're going to round this 1 decimal place. So let me show you how I would punch that in. So I'm going to go to the calculator. So I will do the ln, and it was 8 divided by 5.86, and then close parentheses. So that's 1 ln, okay? and put it in as a quotient or division. And then that answer divides by the 0.0212. All right, we're estimating it 1 decimal place. So y'all, that looks like what, 14.6, but the next number is an 8, so we'll round that to a 14.7. Okay, y'all, but we knew it had to be more than 6 years what we got a while ago, okay? All right, then let me see for D. So D, it says the doubling time is blank years. Now I got another formula I use for doubling time. And it comes out of the formula we're looking at. But doubling time is a capital T equals the ln of 2 divided by RK. Now we know K, we already got it up here. It's 0.0212. Remember, it's got to be in decimal form. So the doubling time will be the ln of 2 over 0.0212. Now what the doubling time is it's the amount of time it takes your population to double or your investment to double, okay? So let's look, so it's 8 million, so doubling it, we're basically finding how long it takes it to get at 16 million. Now this one, I'm rounding 1 decimal place also. So y'all, let's go punch that in. We got the ln of 2. So the ln of 2, close those parentheses, divided by 0.0212. All right, y'all, remember I'm going to round it 1 decimal place. So that's going to be 32 point, well, the 6 got a 9 behind it, so that'll be a 32.7. And then remember, that'll be in years. Okay, so using our formula, we've seen that it took almost 15 years to get to 8 million. It takes almost 33 years to double, okay? All righty, so the main formulas were the one I gave y'all up here. P of T equals P initial E KT. And then this one for doubling time. And then I'll show you one how you find the growth rate, okay? So y'all, basically 9.7 is just plugging into these formulas, okay? So for number 2, they want me to complete the following table. So they got 3 columns: population, growth rate, K, and then doubling time, T. All right, so the population, there's 2 countries. They got country A and country B. Now for country A, they gave me its growth rate was 1.2% per year, which means when I find the growth rate of country B, it's going to have to be in percent. So I got to turn the decimal back into a percent by moving it right 2 places. Now on the doubling time, they didn't give me country A's doubling time. They gave me country B's doubling time was 27 years. So I'm looking for the growth rate of country B and the doubling time of country A. So y'all, let me give you the two formulas. Double time was the big T equaled ln of 2 over K. Well, the growth rate, K, is K equals the ln of 2 over the doubling time. So they basically using the same formulas. I'm just flip-flopping them for the one I need to find, okay? Now, I guess I'll find doubling time of country A. So there we go, country A, doubling time. All right, so that means a big T will equal to ln of 2 over the K. But y'all look, they're giving me that as a percent. That 1.2% has to be turned into a decimal. So we're going to move that left twice. So that's going to give us a 0.012. Remember, in the formulas, you got to be in the decimal form. So 0.012. Now notice, on the doubling time, this one is in years. So they're going to want us to round the doubling time to the nearest year, okay? All right, y'all, so we're just going in and punch that in. Let me let one in real quick. We're going to go punch in ln of 2 divided by, so let me get my calculator set. So we're going to do the ln of 2, close parentheses, divided by 0.012. All right, we're rounding to the nearest year, so there won't be any decimal places. So let's see, I got what, 57.7. That's going to round my 7 up to an 8. So that's going to give me 58 years. All right, so Math Lab, this is 58. So you would put your 58 in here, and they've already got the years written out here, okay? So now we need to find country B's growth rate. Well, that's going to use the growth rate formula. K is going to equal to ln of 2 over its doubling time. Well, we know the doubling time for country B was 27 years. So 27 goes in for the T, okay? Now, let me see on this one. We're going to round it one decimal place, just like their growth rate was, okay? So let's go back in, calculator. Will be ln of 2, close parentheses, divided by 27, which was my doubling time. Now remember, I'm rounding it one decimal place, but y'all, I'm getting at the moment 0.02567. I'm going to go out about 5 decimal places for a second. Because remember, to convert the decimal back into percent, I'm going to move the decimal right 2 units. So moving it right 2 units, I'm going to get a 2 point. Well, y'all, that 5 has a 6 after it, so I'm going to round that 5 into a 6. Now they will already have the little percent here. All we got to do is put in 2.6. Okay, so the only one you really got to worry about converting is convert decimals back into percents, and then up here you had to do percents in the decimal. So this one we got to convert to percent form. Okay, and then up here we had to convert to decimal form. So that's the main thing you got to watch out on these is how do they want that answer, and look for how many decimal places they're using, okay? All right, y'all, so now let's look at this same formula, but we're going to do it for investments, okay? All righty, so let me see here. Let me turn this paper. All righty, so for number 3, now this is the last of the long ones. The next 3 will be pretty quick problems, okay? So this one says, suppose 14,957 is invested at 6.4% compounded continuously. Now, when we had daily compounding, semi-annual, quarterly, we used the other formula where it had the remember my beginning amount, then I had the 1 plus R over N. Well, this is continuous compounding. We used the formula we just came up with a while ago. So for part A, find the exponential function that describes the amount after t years. So that describes the amount in the account after t years. So this is just like on the first question. They just want me to come up with a formula. So let me see. I think once again they give us the P of t. We just got to fill it out, okay? So remember, PO is my initial amount. Well, that's the 14,957. Then we got our E. K is the growth rate or interest rate. So K is going to be 6.4%. But y'all, we need to turn 6.4% into a decimal. So y'all, what do y'all get on that when you turn that into a decimal?
Point 0.064.
So that'd be 0.064. So it's going to go for K. And then we put our T. So the basic formula that we'll use is the 14,957 e to the 0.064 times T. Now B, they want to know, what is the balance after t equals 1 year, 2 years, 5 years, and 10 years. Okay, so this will have a, so they'll say after 1 year, what was next? After 2 years, after 5 years, and then after 10 years. Now, the one thing we do know on this, since it's an investment, those better go up every year, okay? Now, let me see. They want me to round it 2 decimal places. So I'm going to show you how to do this on your calculator, okay? So I'm just going to go punch that into my y equals. You know, I'm going to clear the side over here. Now, I'm going to put in my formula, 14,957 E, so I'm going to use the second ln to get the E with the exponent, and then it'll be 0.064. Now, instead of T on here, we got to use the X, okay? All right, so I got my equation in, and I don't even care about the graph. I want to look at the table. So I'm going to go to second graph to my table. And let me arrow down until I get to what they want up here showing. So here is 1 year. Now I want y'all to see, it ain't showing decimal places, but if you'll get on the Y values and look below, it says Y1 equals 15945 point. That right there is where I'm going to get my decimal answers at, okay? See, the Y values on the table are actually rounding them off, but when you click on each value, you get the decimal form of it. So after 1 year, this would be 1,005,945 point. So 2 decimal places will be 54. And since there's a 4 after, we don't round up, so we'll keep that 54. Now, next was 2 years. So 2 years, when I click on that Y value, I get 16999 point, looks like that'll stay 42. Next was 5 years. So let me go down here to where I had X value of 5. That is 20,597 point, y'all look at that, 699. That's going to round everything up to a 0.70. Since I got to round that 9 up to a 10, basically, that means the 6 becomes a 7, okay? Now, 10 years, let me scroll down. So that was 7 years, 8 years, 9 years, 10 years. So that is 28,365 point, what we got, 66, got a 4 after it, so we're going to keep that a 0.66. Now, the other way you could do that would be to punch them each in individually using your formula. So you could do the 14,957, do the second LN, and then we would have what, 0.064 times 1. So all you're changing is the exponent, 1, 2, 5, and 10. But y'all, you can punch them out individually, but it gives me the same answers as the table did when I click on each of those Y values, okay? So if you do it this way, you gotta actually put the program, use the formula 4 times. All right, y'all. Then part C, they say the doubling time is blank years. All
I
right,
have
so
a
we
question
had
real
our.
quick.
Okay, I heard. What was that?
Um, so I have a number that will round to 10. Like it's a 9, but it's got an 8 next to it. So do I put a 0? I can't put a 10, can I?
No. So what's your number actually?
It's 15247
Uh huh.
point 17935.
Okay. Well, you got enough. So the only thing
Okay.
that's happening on yours, since yours is 2 decimal places, will be the 1-7. Only thing that's happening is that 9's making that 7 into an 8. So yours
Okay.
15247.18.
Okay. Thank you.
What you got to worry about is if you would have had a 0.199,
Yeah, then what do I do?
then the 9 would have turned into a 0, and it would have made the 1 turn into a 2.
Okay.
Okay, so you really just got to worry about doing that if you got them 9s in that last digit. Okay.
Okay. Thank you.
Uh-huh. All right, y'all remember doubling time was a big T equals ln of 2 over my K. So I'll tell you what, if y'all ever invest money and you want to know how long it's going to take you to double that money, all you got to do is take ln of 2 and divide it by your interest rate. Okay? And that'll tell you how many years it'll take you to double your actual money. All right, y'all, for us, we got ln of 2 over K. Now remember, my K was what, 0.064? So y'all, I'm gonna go punch that in and see what we get. So I got a ln of 2 so ln of 2 divided by 0.064. And y'all, I'll tell you one of the biggest mistakes I get on this is people forget to close them parentheses on that too, okay? All right, now we're looking for years, and they're rounding this 1 decimal place. So y'all, looks like I'm getting what, a 10.8? Yeah, because that's a 3 after the 8, so we'll keep that 10.8, which is almost 11 years for these people to double their money. So if they started out at 14,957, after 10.8 years, they're going to have about what, 30,000 or so, okay? Alrighty, so the rest of these aren't bad. You're just plugging in for the time and getting what they want, okay? So let me show you one like number 4 here. So this says the number of books in a small library increases according to the function so they're giving us the formula. So they got a B equals 3,700 E to the 0.02 T. And then it says where T is measured in years. So they're giving us the formula we're using. They want to know how many books would a library have after 2 years. So how many books will the library have what I say after 2 years? So you're using the same formula. All you're doing is putting a 2 in for the T since it's 2 years, okay? So we'll have B, and I'm supposing B means how many books they'll have. So it looks like they started out with 3,700 books. So when we're done, we're looking for something more than that, okay? So we bring down our 3,700 E to the 0.02 times our T, which was 2 years. Now let me see, they want us to round. We're rounding it to the nearest book. Now these are multiple choice answers on this one, okay? So they've got the 4 answers on these last 3 problems. So you just gotta round to the nearest book and then pick a choice, okay? So y'all, let's go to my calculator. So I had 3,700. Second ln to get my E. And then I had 0.02 times 2. All right, y'all, so let's punch that in. So look at that. Now, round this one to the nearest book. So I won't have any decimal places on this. What would y'all round that to? So I know we're starting out with what, a 3, 8.
51.
Say again?
Is it 3851?
3851. Good job. Yeah, because that had a 0.9 after it, so that 9 kicked that 0 up to a 1. Okay, y'all. So notice we got 3851. We'll notice their answers. 3851, 4,000, 11,000, and 5,000. Okay. So you'll be able to tell pretty easy which one is your actual answer. Now, I will say 5 is the same kind of problem. So I'm going to go to the number 6 because it is a sort of like a decay. So for 6, it says the number of acres in a landfill is given by the function all right, given by the function. So this one is B equals 3,800 E to the negative 0.05 T. And once again, T is measured in years. Well, they want to know how many acres will the landfill have after 9 years. And it says round to the nearest acre. So once again, we won't have no decimal places. So y'all, I'll let y'all have fun with that one. Now I'll give you the 4 answers they're giving us. And see which one y'all come up with. A, B, C, or D. And these are all in acres. All right, y'all. So tell me, after 9 years, how many acres will my landfill have? And since that's a negative there, we know it's going to go down on this one, okay?
D 24.
Is it D?
Oh, y'all say D is in dog or B is
Yes.
in boy?
D is in dog.
D is in dog. Perfect. Okay, so y'all, that and we did what? Our 3,800 E negative 0.05 T, which was 9 years. So once you punch that in and get your answer. Yeah, because that gave us what? 2422.9869. And that rounded off to what? 2423, okay? So y'all, that's 9-7. The first three, you sort of had to play with the formulas. The last three, you're just finding what your T is, plugging it in, and evaluating it, okay? And all those were rounded to the nearest acre, the nearest dollar, or whatever, okay? Alrighty, so the other thing I wanted to show y'all tonight was 9.6 support. Because I sent y'all the 9.6 video on the college algebra part. But the support was mainly just getting you ready for cross multiplying. And I think all these said solve. So I'm going to show you how I would solve these. So y'all, number one had a x minus 8 over x plus 3. This all equals 1/2. So y'all, anytime you see a fraction equal to a fraction, the way you're going to do that, you're going to cross multiply. By cross multiplying, that's the easiest way to get rid of the fractions. But what you got to remember, when I cross multiply, I'm going to take this whole top, this x minus 8, and I'm going to multiply by the 2. So basically, the 2 is going to have to multiply by both of these. So the 2 times the x gives me a 2x. And then that 2 times that negative 8 makes that a negative 16. Now you do the same thing. You take the bottom of the first fraction and multiply by the top of the second fraction. So x times 1 is an x. Positive 3 times 1 is a positive 3. Now at this point, solve for x. For you ought to do that, I'm going to subtract this. I'm going to try to get all the x's on the left side. So I would subtract x from both sides. So 2 minus 1 left me 1x minus 16 equals 3. And y'all, add 16 to both sides and be done. So that my x equals 16 and 3 is 19. Okay. So the first three, that's all you're doing. You're cross multiplying. And all of them will be done just like that. Now, for number 4, Number 4 says solve. They're giving me a v squared minus 6v minus 16 equals 0. Now, I'm going to show you a trick I do to these. I graph these in y equals just to see if I can find any x-intercepts. Because if you can find x-intercepts, you got your answers. There's going to be 2 answers because that's a v squared, right? So I'm going to go to my calculator and graph it just to see if I can see where this is crossing the x-axis. Or you can factor that or use the quad formula, okay? Now, instead of v's, I'm going to use x squared minus 6x minus 16. Now, I just want to see the graph just to see if I can see where it's crossing the x-axis. So I'm going to graph it. And y'all, I can tell right where it's crossing the x-axis. Looks like it's crossing here at -2. And then let's see, 1, 2, 3, 4, 5, 6, and +8. Now, if you want to make sure, go to the table. So 8 has a 0 like I need. So let me go up to -2. And -2 has a 0. So that means v equals -2, 8. So if you're weak at factoring, graph them and see what you get, okay? So one way I did this, I graphed it, okay? In y equals. The second way you could have done that is you could have factored that. So the v squared would be a v and a v. Now remember, the last number's negative, so you got unlike signs. And you're looking for factors of 16 that subtract to get 6. Well, let's see. 16 is 1 and 16, 2 and 8, 4 and 4. So the ones I needed were 8 and 2. So since you got unlike signs, the larger factor has to be negative like the middle. And then the 2 would be positive. But notice, we got it factored. So at this point, we would set these equal to 0 and change those signs. So that v is a -2, like I got by graphing. V is a +8, the same as I got when I did my graphing. All right, y'all, then there was one more of those. And this one actually says solve by factoring. This would be like number 5, okay? So this one said 5x squared minus 7x minus 12 equals 0. Now, I'll show you how to get this by graphing. Usually when it's got a number in front, remember, I got to change my table a little bit. But watch this. I'm going to show you how to get this by graphing. I'm going to go y equals and clear that out. And now let me clear the side over here. So 5x squared. So 5x squared minus 7x minus 12. Now I want to graph it first, but usually when you got a number in front of the x squared, one of your answers is probably going to be a fraction. So let's see what we get just putting it in first. So I'm going to graph. Now, y'all, the one on the left side, I can tell that's definitely a -1. But the one on the right side is in between 2 and 3. So watch this. When you go to the table by hitting second graph, there's my y equals 0 at -1. But between 2 and 3, there's no numbers there yet. So remember what I did on those? I'm going to go to second window to get my table set. And I'm going to go down here to where it has the triangle at, remember? That's the change in the table. Since my equation had a 5 in the front, the change in table has to be a 1 divided by 5. Whatever number's in front of the x squared, you'll have 1 divided by that number, okay? Now look when I go to my table. I'm going to hit second graph to go to the table. Now remember, that was in between 2 and 3, so let me arrow down. So there's 0, there's 1, there's 2. Oh, look at that. In between 2 and 3, I got a y value of 0, and they're giving me a 2.4. So I'm going to turn 2.4 into a fraction. So 2.4, if I hit math and enter twice, 2.4 is actually 12/5. Now, I'm going to fix my table back before I leave. I'm going to go to second window to pull up my table. Now, you always wanted to start on a whole number, so I always started at 0. And then down here where we got 0.2, we need to change that back to a 1. Now, when I go back to my table by hitting second graph, it's back to normal, okay? So if you change the table, go back and change it back for future use. So, whoops. So I would go in. So my answers would be x equals the 12/5 that we got and the -1. So that's the easiest way to do these. Or the other easy way, well, not so easy, but you could plug it into the quad formula using your A, B, and C. Whew, but that takes a lot of work on that quad, okay?
And how did you plug that into the computer again?
Into my calculator.
Yes, calculator. My bad. I'm sorry.
Uh-huh. So here's my equation: 5x squared minus 7x minus 12.
And you
Are you
put that
actually,
into y equals.
are you actually doing this?
Yes, I am.
So what
Let's
is
watch
your,
and see how you do it. Oh,
what's
mine
what's
is
your
mine is 3n squared
3n
plus
squared?
3n squared plus 13n plus 10 equals 0.
Equals 0. Okay, so on this one, let's go to y equals and put that in first.
Yes, sir.
So I'm gonna go to y equals, I'm gonna clear that out. Now instead of n's, I'm putting x's. So 3x squared plus 13x plus 10. So we want to graph that first, just to see if we can see where it's going over.
Okay.
Now, I'm looking at that. It looks like it's definitely crossing on the -1 on the right side of that parabola.
Yes, sir.
Now, that left side looks like it's in between, what, -3 and -4.
Yes, sir.
So if I go to the table, I'm going to verify that that 1 is that -1 real quick. So there you go. At -1, I got a y value of 0, okay?
Okay.
So since I only seen one of those, I want to get that other one. So I'm going to go to second window and we're going to set our table. Now, your first number was a 3, so we want your table to be 1 divided by 3.
Okay.
Now, we don't have to worry about the graph. We're going to go back to that table. So hit second graph and go to our table. So remember, that was in between what I say, 3 and 4 on the negative side, or 2 and 3. So let me arrow up until I can get that other one. So I'm at -2, -3. Oh, there it is. At -3.33333. So I'm gonna go try to turn that into a fraction in a second.
Okay.
But first I'm gonna set my window back. So hit second window, and we're gonna start that at 0 again. And we're going to change the triangle table to a 1, okay? That way, when we go back to our table, we're back to normal numbers.
Okay.
All righty, so quit that screen. And I had -3 point. Now, you might have to go out extra digits on this. Let me see if it'll turn this one into a fraction. So I'm going to hit math and enter twice. So we need more 3's on it, okay? So I'm going to do -3 point. So if you get one like this, punch a bunch of 3's because that thing goes on forever
Okay.
for thirds. And then we'll hit math and enter twice. So it took enough 3's that made that a -10 thirds. So one of your answers would be that -10 thirds. The other answer, what did we say, was that -1?
I think so. Yes, sir.
Yeah. So a -1.
Okay. Thank you.
Yeah. So y'all probably gonna get the first one pretty quick. The second one on number 5, you're just gonna have to change it. 1 divided by whatever y'all's first number is, okay? And then that'll get that second one pretty quick. So really, that 9.6 stuff is mainly almost like a review of all the different ways to solve these equations, okay, y'all? Alrighty, so that's all the new material I got. So do y'all have any questions on that? So it's just plugging into your formula, okay? And the main thing you got to remember on that formula is converting those decimals into percent or the percents into decimals. All right, y'all, so I'll quit this recording. So do y'all have any other questions?